The National Electrical Code, Section 250.104b, addresses bonding requirements for metal gas piping systems. This section mandates a supplementary grounding electrode system in buildings where the gas piping exists and the primary grounding electrode system is insufficient for the building's electrical service. The goal of this supplementary system is to ensure that the gas piping is properly bonded, minimizing potential hazards. It's crucial to understand that a ground rod should not be used as a substitute for a properly installed bond wire. While a ground rod provides a path to ground for lightning strikes and other transient overvoltages, it doesn't establish the necessary electrical connection between the gas piping system and the building's grounding system. In many instances, the gas piping is already bonded to the building's grounding electrode system through the incoming gas service line and the meter. Before undertaking any additional bonding measures, it is imperative to verify that this existing bonding connection is present and in good condition. This verification process involves inspecting the gas service line and meter for a visible bonding connection, ensuring that the connection is secure and free from corrosion. If the gas piping is not adequately bonded, you must install a supplemental grounding electrode system. This system can include a bond wire connected to the gas main. The bond wire's purpose is to create a low impedance path for fault currents, ensuring that the gas piping is at the same electrical potential as the grounding system. This helps to prevent dangerous voltage differences that could lead to arcing and potential ignition of gas. When installing a bond wire, adhere to the National Electrical Code requirements for sizing and installation. The code specifies the minimum size of the bonding conductor base and the size of the service entrance conductors. Refer to NEC Table 250.102 code to determine the correct size of the bonding jumper. Ensure the bond wire is connected to the gas piping as close as possible to the point where the gas service line enters the building. This minimizes the impedance of the bonding path and ensures that the entire gas piping system is effectively bonded. Securely attach the bond wire to the gas piping using listed bonding clamps or connectors. These connectors are designed to provide a reliable, low-resistance connection that will withstand corrosion and mechanical stress. In existing or finished homes, accessing the gas piping for the bond wire connection may require some minor modifications to the building structure. It might be necessary to make a small hole in the drywall or other wall coverings to gain access to the gas piping. Exercise caution when making these modifications to avoid damaging the gas piping or other building components. When dealing with electrical inspections, an authority having jurisdiction, effective communication is essential. If an inspector requests a ground rod as a substitute for a bond wire, respectfully explain that a bond wire to the gas main is the required supplemental grounding electrode system according to NEC Section 250.104b. Emphasize that the ground rod does not provide the necessary bonding between the gas piping and the building's grounding system. To support your position, provide the authority having jurisdiction with a written letter or code reference clearly stating the NEC requirements. This documentation will help to clarify the code requirements and ensure that the inspection is conducted in accordance with the NEC. Here is a summary of key points to consider. Firstly, always verify the existing bonding of the gas piping system before installing any additional bonding components. Secondly, install a bond wire to the gas main as the required supplemental grounding electrode system for NEC Section 250.104b when necessary. Thirdly, never substitute a ground rod for a bond wire, as it does not provide the same level of protection. Fourthly, ensure that the bond wire is properly sized and installed according to NEC requirements. Fifthly, communicate effectively with the authority having jurisdiction and provide documentation to support your position. To further illustrate the importance of proper gas line bonding, consider the potential consequences of inadequate bonding. If the gas piping is not properly bonded, a voltage difference can develop between the piping and other grounded metal objects in the building. This voltage difference can lead to arcing, which is the formation of an electrical discharge through the air. In an environment where natural gas is present, arcing can ignite the gas, leading to a fire or explosion. Therefore, proper gas line bonding is a critical safety measure that protects the building and its occupants from potential hazards. In addition to the NEC requirements, local codes and regulations may also apply to gas line bonding. It is essential to consult with the authority having jurisdiction to determine the specific requirements in your area. These local requirements may include additional bonding requirements or specific installation methods. Always comply with all applicable codes and regulations to ensure that the gas line bonding is performed correctly and safely. The proper sizing of the bonding conductor is vital for effective grounding. The size of the bonding conductor is determined by the size of the service entrance conductors to the building. Refer to NEC Table 250.102 current for the specific requirements. Using an undersized bonding conductor can limit its ability to carry fault current, potentially compromising the safety of the system. Conversely, using an oversized bonding conductor is generally not a problem, but it can increase the cost and complexity of the installation. Select the appropriate size bonding conductor based on the NEC requirements and ensure that it is properly installed and connected. The connection of the bonding conductor to the gas piping is another critical aspect of proper gas line bonding. The bonding conductor must be securely connected to the gas piping using listed bonding clamps or connectors. These connectors are designed to provide a reliable, low-resistance connection that will withstand corrosion and mechanical stress. Avoid using makeshift or unapproved connection methods, as they may not provide adequate electrical contact and could fail over time. Clean the surface of the gas piping before installing the bonding clamp or connector to ensure a good electrical connection. Remove any dirt, rust, or other contaminants that could interfere with the connection. Tighten the bonding clamp or connector to the manufacturer's specified torque to ensure a secure and reliable connection. Regular inspection and maintenance of the gas line bonding system are essential for ensuring its continued effectiveness. Periodically inspect the bonding connections for corrosion, damage, or looseness. If any problems are found, repair or replace the affected components as necessary. It is also advisable to test the resistance of the bonding connection to ensure that it is within acceptable limits. A high resistance connection indicates a potential problem that needs to be addressed. Keep a record of all inspections and maintenance activities to track the performance of the gas line bonding system over time. In addition to bonding the gas piping, it is also important to bond other metal objects in the vicinity of the gas piping. This includes metal water pipes, metal ductwork, and metal appliance housings. Bonding these objects together helps to create an equipotential plane, which minimizes the potential for voltage differences and reduces the risk of arcing. Use bonding jumpers to connect these metal objects to the gas piping or the building's grounding system. Ensure that the bonding jumpers are properly sized and installed according to NEC requirements. When working with gas piping and electrical systems, it is essential to prioritize safety. Always turn off the gas supply before working on the gas piping system. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with gas piping or electrical systems, hire a qualified professional to perform the work. Improper installation or maintenance of the gas line bonding system can create a safety hazard. Furthermore, consider the type of gas piping material when implementing a bonding strategy. Steel and copper piping will behave differently under fault conditions compared to newer plastics and composites used in gas delivery. Branding clamps must be compatible with the piping material to prevent corrosion or loosening over time. The location of the bonding connection relative to the gas meter and any unions in the piping is important. Ideally, the bond should be placed as close as possible to the meter on the customer side and upstream of any unions or insulating fittings. This minimizes the potential for arcing across these components. Consider the environmental conditions when selecting bonding hardware and conductors. In coastal areas or other corrosive environments, use materials that are resistant to corrosion, such as stainless steel or copper. Protect bonding connections from exposure to moisture and chemicals to prevent deterioration. The use of dielectric unions and gas piping systems can present a challenge for bonding. Dielectric unions are designed to electrically isolate different sections of piping. If a dielectric union is present in the gas piping system, it is essential to bond both sides of the union to maintain electrical continuity. Use a bonding jumper to connect the two sections of piping together. The bonding jumper should be sized and installed according to NEC requirements. The increasing use of plastic piping in gas distribution systems presents new challenges for bonding. Plastic piping is non-conductive, so it cannot be directly bonded to the grounding system. In these cases, it is essential to bond any exposed metal gas piping components such as risers and appliance connectors. The bonding connection should be made as close as possible to the plastic piping to minimize the potential for voltage differences. In addition, it is important to ensure that the plastic piping is properly supported and protected from physical damage. Proper documentation of the gas line bonding system is essential for future reference and maintenance. Keep a record of all bonding connections, including the location, size, and type of bonding conductors and connectors. Include a diagram of the gas piping system showing the location of all bonding connections. Store this documentation in a safe and accessible location. This documentation will be helpful for future inspections, maintenance, and repairs. In addition to the NEC requirements, there may be other industry standards and best practices that apply to gas line bonding. Consult with industry experts and organizations to learn about the latest recommendations for gas line bonding. Stay up to date on the latest codes, standards, and best practices to ensure that your gas line bonding system is safe and effective. The use of surge protective devices can further enhance the protection of gas piping systems from lightning strikes and other transient overvoltages. Surge protective devices are designed to divert surge currents to ground, preventing them from damaging sensitive equipment and reducing the risk of fire. Install surge protective devices at the service entrance and the other strategic locations in the electrical system. Ensure that the surge protective devices are properly grounded and bonded to the gas piping system. The NEC provides specific requirements for the grounding and bonding of surge protective devices. Proper coordination between the electrical system and the gas piping system is essential for effective gas line bonding. The electrical system and the gas piping system should be designed and installed in a coordinated manner to ensure that they work together to protect the building and its occupants. Consult with qualified professionals to ensure that the electrical system and the gas piping system are properly coordinated. This coordination should include the selection and installation of grounding and bonding components, as well as the implementation of appropriate safety measures. The gas meter itself is a critical component of the gas piping system and should be properly bonded. The gas meter is typically connected to the gas service line and is often located near the point where the gas service line enters the building. The gas meter should be bonded to the building's grounding system to ensure that it is at the same electrical potential as the rest of the system. Use a bonding jumper to connect the gas meter to the grounding system. The bonding jumper should be sized and installed according to NEC requirements. The gas meter should also be protected from physical damage and corrosion. Regular inspections of the gas meter and its bonding connections are essential for ensuring its continued safety and effectiveness. In summary, gas line bonding is a critical safety measure that protects buildings and occupants from potential hazards. Proper bonding of gas piping systems is essential for preventing voltage differences, reducing the risk of arcing, and minimizing the potential for fire or explosion. Always follow the NEC requirements and consult with qualified professionals to ensure that gas line bonding is performed correctly and safely. Regular inspection and maintenance of the gas line bonding system are essential for ensuring its continued effectiveness.